Welcome back to the unit circle supplement day 1. So far we've looked at how to sketch angles on the coordinate plane in example 1, clip 1, covering most of this information at example 1. We are now going on to clip 2, being able to find coterminal angles. You're being asked to find one positive and one negative coterminal angle. And when we do this, it's supposed to be within at least within one rotation from it if possible to keep us consistent, but it could be more rotations than that. And then write an expression modeling all angles on the coterminal to the given. Well, when I'm talking about rotations, I'm talking about going around 360 degrees, spinning around 360 degrees. So I have this, and I have this initial ray. This initial ray being right here, and it spins around. It's done a full rotation. If it stopped here initially, if it started here and stopped here initially at 45 degrees, that would just be a 45-degree angle and in quadrant 1. But if it goes around once and then stops, then it's no longer 45 degrees, it's 360 plus the 45 degrees. And it could keep spinning around infinitely if it really wanted to. It could keep spinning and spinning. I could spin it 10 times. So 10 times 360, 3,600 degrees. And then stop it here at the 45, so that'd be 3,645 degrees. All of them would have the same terminal ray. And that's what it means to be coterminal. To have the same, they all have the same initial ray, right? The initial ray is always the x-axis.
This concludes our first.
So our initial ray is always the positive x-axis. But what it means by this coterminal, meaning that they, like co-workers, they work together. They are together or at the same place. They share the same terminal ray, although for one angle it's spun around the circle less times or more times than the other. So 90 degrees is our first one. We look at the 90-degree angle, that's easy enough. Here is a 90-degree angle. But I don't have to stop at 90 degrees. I could, if I wanted to, go completely around the circle one time, one revolution in this case being 360 degrees. It'll be something different when we start measuring in radians, but right now we're only working in degrees. One revolution is 360 degrees. And so if we've done 360 degrees to go from here to here, and now we're going that additional 90 again, so that we end up in the same place. That's the same as 360 plus 90. 360 plus 90 is 450 degrees. So that's one positive coterminal angle with 90. Now the other thing is also true. We could also go the other direction. We could start here and we could spin it around in a negative direction and end at the same place. Well, it wasn't starting there, it was starting here. So if we started here, and I need a different color, and we went in a negative direction, we don't even have to do a full revolution. We can end right there. And I don't have to do the math here. You already know that that's negative 90, negative 180, negative 270 degrees for this, for letter A. 450 is one positive because it went around one full revolution. And then again, the 90 degrees to end at the same spot. Negative 270 is going in the opposite direction to the same terminal ray, 90 degrees being our terminal ray. Now how could I get that? I could have done 90 minus 360. Hey, your terminal ray's at 90. Well, let's spin it around in a negative direction one time and come right back to it. Well, 90 minus 360 is negative 270, so that works. Let's take a look at letter B because it's a little bit different when we start with negative angles. Not really, not in terms of how we do it, but in terms of how some people think about it. So negative 20 we know is going to fall in this first quadrant right here. We'll say that there's our terminal, here's our initial, there's our terminal ray. That is negative 20 degrees. Well, you could go even more negative to get another negative degree. You could spin it around, starting here, go around 360 and then stop there. And so that's an additional, that's a negative 20 by the way. So that's an additional negative 360. So it's negative 20 plus negative 360, which is negative 380. Negative 380 is one of the coterminal. And then for a positive coterminal, instead of going in a negative direction, I could have gone in a positive direction from my initial ray, almost full circle, but not quite full circle because I end at that terminal ray, which is 20 less than 360. So that's negative 20 plus 360, which is going to be 340 degrees. Let's take a look at letter C. One more example before I ask you to try letters D and E. For letter C, here is X, here is Y. We know that in a positive direction, that's 0, 90, 180, 270, 360. So 135 has an initial ray on the positive x-axis, and then somewhere here in quadrant 2. It's not exact, but it's a rough estimate. It's probably going to split that in half. So anyhow, so we've got 135. There's my 135 degree angle. But I didn't say you had to stop there. You could have spun in that positive direction another full 360 degrees first and then come up and around and ended at the same place.
Teachers.
So that would give you 360 plus 135 or 495 degrees in a positive direction, sharing the same terminal ray. The other direction that I could have gone was a negative direction from this ray. I could have gone to the left, gone clockwise, and that would be, it didn't go 180 degrees, it stopped 135, or sorry, it didn't go a full 360 degrees, it stopped a whole full 300 or 135 short of that. So 360 minus 135, so I've got 125, oh, no, that's not right. I didn't have to borrow from this. That's just a 5. Sorry, 225 degrees. 225 degrees, a negative 225 degrees. Please pause the video and try this for letters D and E. For letter D, I'm starting out with a negative 100 degree angle, which I have drawn here. And I realized that it didn't have to stop there. It could have spun around an additional negative 360 degrees. So it could have started at the same initial ray, gone a negative 100 degrees, and continued spinning another 360 to end there. So negative 100 minus 360 is negative 460 degrees to end at that same terminal ray. One in the positive direction, well, it didn't have to go that direction. It could have started at this initial ray and gone counterclockwise to end there, which would be my just shy of going a full 360 in the green by 100 degrees. So I'd be 360, or sorry, negative 100 plus 360 degrees, which is 260 degrees. On letter E, we have a 200 degree angle to begin with. We could spin around an additional 360 degrees if we wanted. So it went around one time, 360 degrees, and then the additional 200. 200 plus 360 gives us 560 degrees as one of the coterminal angles. We could have also gone in the negative direction from this initial ray, and instead of going a full 360, we're 200 degrees short of that. So 200 minus 360, or negative 360 plus 200. So 360 minus 200 is 160. So this is negative 160 degrees. Negative 160 degrees. So there we have it. To find coterminal, we can either continue adding 360 to it to continue doing more revolutions and ending at the same terminal ray, or subtract 360 from it to get more coterminal rays, more rays that end at the same terminal ray. This concludes the video example for example 2 of day 1. Please be sure to watch example 3 of day 1 as well.